Right, we've got a question here, and it's looking as if it's going to be fairly complicated. Okay, I've got both languages going on here, but there's a lot of information. One thing you should spot straight away is that I've got tons and newtons going on, and of course a newton is measured in kilograms and tons are thousands of kilograms, so you've got to remember that the aspect there is a 10 to the 3 aspect that you've got to work on. Now I can only, in these sorts of situations, draw really simple diagrams. I'm not an artist. In fact, I'm a bearer of a very small brain, so I have to actually always reduce these questions down to a simple diagram. My acceleration will be going left to right. I have a force going in that direction, looking at the picture anyway, and that force is the driving force of the locomotive. Okay. Don't know it on this particular page, but we'll work on that in a second. I've got a mass acting down, which in this particular case is not really appropriate, but I've got 90, 30 and 30. That's 150 tons, so it's 150,000 G. I don't need the G in this question, but I might as well have it. And I've got a resistance acting against my force, so this is my driving force, if you like. Little f for driving, it doesn't make any difference what you use. And I've got a total resistance. Now you can see the resistance acting back is 2,000 plus another two lots of 500, so it's 3,000 newtons acting back. And because I've actually gone and considered that 1,000, all my units are reasonable. So I need a simple diagram. Now that diagram, as soon as you put that force diagram in, you're starting to gain marks, you're starting to understand the questions that are going on here. Okay, so I'll flick on to the next page. So I've got a driving force now of 12,000 newtons. So question asks me to find the acceleration, so it's clearly a Newton's second law, N2L. Force equals mass times acceleration. You notice I said on my previous page that I didn't really need the G in there because that would be the weight, and if I had a resistance coming into these sorts of questions, then that would be something to consider. But in this particular case, my mass is 150,000 kilograms. Don't need to write the kilograms in, but never mind. Acceleration is what I'm trying to find, so clearly I need to know the force. And what I did was I actually had a positive sense. My acceleration I had going from left to right in the usual positive sense. So therefore my force is going to be my forward force going that way, which my question tells me is 12,000 newtons, less my resistive force, which I think was 3,000 newtons. There was 2,000 for the train, 500 each for each of the carriages. Very short train with two trucks, but never mind. So my overall force is my 12,000 minus my 3,000, which clearly gives me, last time I checked, 9,000. Okay, so if I stick that into force equals mass times acceleration, I'm going to get 9,000 equals 150,000 A, and clearly my A is going to be 9,000 divided by 150,000. Make sure I get enough zeros on there. 9 over 150, which is 3 over 50, and if you prefer 0.06 meters per second. End of problem. And so it's a nice easy situation, and my diagram in the first place helped me work out exactly what was going on. It's always useful in these questions to have a direction that you're working on. Keep that number in mind because we're going to need it later on. You can actually write it as a fraction if you want, it doesn't make any difference. Decimals are perfectly good. And in this part of the question, the second part of the question, I've got to find the tension in the coupling between the trucks A and B. Now, if I just consider my truck B, it's got a mass of 3,000 kilos. It's got a resistive force, so I need 30,000, behave yourself, kilograms acting down, so 30,000 G acting down. I always like to put G in there. It's accelerating forward. Now we know that it's accelerating forward because we had that 3/50 from before. I've got a resistive force of 500 newtons, and the only thing that's acting forward is the tension in the coupling. There are no other forces in this particular diagram. And again, it's another Newton's second law, because I know the acceleration, I can see the forces. So in this, I'm going to use force equals mass times acceleration again. So I've got T minus 500, and again I'm consistent with my signs because of the direction that I've chosen my acceleration to go in, is going to be equal to 30,000 times my acceleration, which is 3/50, and that will give me a tension of 2,300 newtons. Fairly obviously, I can do a little bit of cancellation here. Okay. And so what I've got is 9,000 divided by 5 plus 500, and that's the way I'll get my answer there. 2,300 newtons. Beauty of these questions is they look as if they're going to be complicated, but if you reduce them down to simple diagrams, they always work easily. As I said, bear of very little brain. Now, I've got another part of the question coming here, and I've done it as 2 slides because I need and I haven't got enough space here to do the particular piece of work. So it's going to give me 7 marks, so I've got to do a reasonable amount of work for 7 marks. So, okay, train is traveling at 10 meters per second, so I've got an initial velocity. I've got a fault occurring in the truck. Its resistance to motion changes from 500 newtons to 5,000 newtons. That's a real error in the braking system there. Driving force becomes 0. Okay. And the train is going to slow down, okay, under the resistive forces until it comes to a stop. Okay, and I've got to find the distance travelled. Now, as mathematicians, we use S for distance, and the reason for that is S, the Latin word for distance, is spatium. And I know in physics they use X, but that does rather suggest that all your motion is along the horizontal axis. And of course, we know that motion can be in all sorts of different directions. So we've got an interesting situation there. Physicists can use X, mathematicians will tend to use S because that's the way we work. So I've got to have all those important little pieces of information. And I've underlined this, and this is not a bad technique actually in underlining things, and it's important that you actually do read these questions carefully, because if you leave out some of that information, then you've got a bit of a problem. Okay, so what I've got, and I need a new diagram here. So I have got that now I've got additional resistive forces. So I've got my trusty diagram. I've still got my 150,000 G acting down that way. I've got no force at all acting that way. My acceleration is going to be this way, but I would anticipate that it turns out to be negative. So again, I'm going to start off with my trusty N2L, because I can't really do much until I've got some further acceleration. The other things I need is I know that my initial velocity is 10 meters per second, consistent units with my other ones. My final velocity is 0. It's stopped. It's important to read those words. So I've got an additional forces. I've got 2,000 for the train, 500 for the truck that's behaving itself, and 5,000 for the truck that wasn't behaving itself, which I think gives me 7,500 newtons acting back that way, no force acting forward. So I've got, looking at the sense that I've got, force equals mass times acceleration, I've got minus 7,500, because it's acting the wrong way, is going to equal 150,000 A. So therefore, fairly obviously that my A is going to be minus 7,500 divided by 150,000. And I could do with getting rid of a few zeros. I got 75 over 150, which is clearly 1 over 20. Over 1,500, not 150, behave yourself. I knew it was 1 over 20. Just had a little brain freeze there. So my acceleration is minus 1/20th, or minus 0.05 if you prefer to work in decimals. Doesn't make any difference to me which way you go. Now, we now need to choose, because we need to find what's going on, the distance that it travels, because we had to get 7 marks worth out of this. So I've got 2 at the moment because I've got my acceleration. I've got initial velocity, final velocity. I've now got acceleration. I want to find distance, and the obvious one to connect those is that v squared minus u squared is equal to 2as. And I am going to stick with S. Okay. So clearly I'm going to get 0 squared, which we know is 0, but I'm putting it in there just to show that I'm really doing the piece of work that I should be doing. Minus 10 squared is equal to 2 times minus 1 over 20. You can tell I'm old school, because I prefer to use fractions, but if you want to use the decimal, that's no problem at all. And that will give me a distance. Clearly I've got a bit of cancellation I can do here. I've got minus 100 on that side, because it is v squared minus u squared. I've got minus 1/10 on this side, so minus 1 over 10 is equal to s. So minus divided by minus hopefully fits our mathematics, and we get my distance is 1,000 meters. And I need to now also find the tension in the coupling. So I've got to do as much work in this final part. And so again, I'm looking at my truck B. It's got a mass of 30,000. Therefore, its weight is 30,000 gram G. Behave yourself. It's got a resistive force of 500 newtons. It's got a tension acting that way, we think, maybe, and it actually has an acceleration of minus 1/20 meters per second. You notice I don't put units on my diagrams, but I always draw a force diagram. And yet again, I'm using my trusty N2L. Now, I didn't write it this time, so I suppose I ought to. It's always a good idea when you're using formulae to make sure you quote them, and quote them properly, because if you misquote it, silly you. Right, force equals mass times acceleration. Okay, so what I've got is T minus 500 because of the senses that we're working in. And that's going to be equal to my mass, which is 30,000. We talked about the fact that the thing was given in tons, and that is multiplied by minus 1/20, because that's the acceleration in this particular case. Okay, and I can do my bestest cancelling out. So T minus 500 is going to be, well, I've got 3,000 divided by 2, which is 1,500, but it is minus. So therefore T is going to be, adding 500 to both sides, minus 1,000 newtons. And the question actually asked me to confirm whether it was a tension or a thrust. Now, clearly my tension is acting in the wrong direction. My positive sense is that way, and I've got a negative tension, so therefore it is a thrust or a compression, whichever you prefer to call it. But you must write those words in. I'm not going to in this particular case.